Hey, this is Jesse with Create This. It is Wednesday, July 15th, 2020. We are in the middle of the COVID-19 pandemic here in the US. It's just ramping up. Kind of a shit show around here. And I am on vacation from work. I took a 1-week vacation and I've been kind of procrastinating, but I've been building up to this project. So this is my 12 volt, 100 amp hour battery. It's a LiFePO4 or lithium iron phosphate Battleborn battery. And I love this thing. I've been using it for about a month now. It has a 120 amp DC Blue Sea Systems breaker here that controls the SB350 forklift connector, and it has a Victron BMV 712 state of charge meter. So those are the main components. It is designed to drop down into a Pelican 1440 case with the lid open. Very, very straightforward. And this particular unit has a number of features for camping that I just installed this past weekend. So it has these two additional Blue Sea Systems breakers, DC. They're both 30 amp, and those control the bottom and the top 45 amp Anderson connectors back here. On the front, we have a Blue Sea Systems 15 amp 12 volt car receptacle, like a cigarette lighter receptacle, and this 10 amp push to reset Blue Sea Systems breaker here. It's a kind of a fused thermal breaker. I don't like these as much as the switch breakers because you can't turn them off, but it's fine for my purposes for this. So the point of these additional accessories on this one is if I take this car camping, I have a 12 volt Engel refrigerator, and I'll plug that in here, and then I can also charge cell phones and stuff like that. We just went this weekend with this and it performed perfectly. It was really cool. The battery lasts about 6 days without recharging, and then if you charge it, it'll also charge from like a gasoline generator or a solar charge controller, a portable solar charge controller. And if you charge it, obviously it'll last longer. But I was really pleased with how it performed. I really enjoyed it. It's light enough that I can pick it up by myself, carry it upstairs. It's not super lightweight. It's maybe 50 pounds, but it's lightweight enough that it's carryable. So I like that. So no charge controller or anything, although I am toying with the idea of installing like a Genasun 14.2 volt lithium charger, MPPT. But anyway, so over here, what we're gonna do today, the whole point of this project is we're gonna tear that bad boy down to its constituent components. And the reason why we're gonna do it is because we're gonna duplicate it. I have 3 additional batteries over there. They're identical batteries, and 3 additional Victron charge control or state of charge meters. And I also have some more components right there. And the whole point of this is we're going to strip this down to its constituent components so that I can clone the various pieces. So the top plate here, I need to clone, I need to trace it and then clone it with a jigsaw. The bottom plate is fairly intricate and that needs to be cloned because all of these are going to fit into their own Pelican cases. Need to clone the side pieces, need to make some new bus bars, copper bus bars here, stuff like that. So that's what we're going to do. I've been kind of procrastinating this project, but I'm really looking forward to it because once I'm done, I will have 4 100 amp hour 12 volt batteries. And because of the SB350 connector, I can experiment with that in different configurations pretty easily. So I will be able to make a 400 amp hour 12 volt battery, and I'll also be able to make a 48 volt 100 amp hour battery. And so that'll be kind of fun for me as a hobbyist. I'm just a hobbyist. I just do this for fun. I don't run my homestead off of this or, run an RV off of it or anything like that. And if I did, I would probably, if I had an RV or a homestead, I would definitely mount these, in a permanent installation. It would just be a lot simpler. But because I might take these out to like a campsite or something, I kind of wanted them to be portable. I wanted to be able to have them out of the vehicle if I needed to and just close the lids and have them watertight. So those are my design constraints. Kind of a weird setup, I know, but I think it's kind of cool. It's kind of fun to play with. So let's get started tearing this guy down. All right, I believe the way that this is designed, there are only 4 bolts holding it down. So These two over here and these two over here hold the top plate on. And then there are 2 bolts attaching everything to the battery. So there's one over here and there's one over here. So let's go ahead and remove the top plate, and then once that is de-energized, it will be quite a bit easier to disassemble everything from the top plate without having to worry about like arc welding a wrench or something. So let's go ahead and do that. And you can also see that as an extra safety precaution, I've got all the breakers turned off. This one obviously doesn't turn off. And also, well, yeah, all the breakers are off. Okay, so the top plate is disconnected, but it's still not going to come off because the copper bus bars are attaching it, so let's remove those next. All right, and here's our positive terminal of the battery. So I don't know how much you know about DC batteries, but 12-volt batteries are really quite safe. You can touch the terminals. You can even touch them with both hands if you want. And you're not going to get shocked. It's really safe to work with. The only risk is if you get a wrench that's metal and you short the 2 terminals. Then you can arc weld your terminals, cause a fire, things like that. So this battery has a battery management system built in, and I suspect it would turn off the current if it arced like that, but you'd still probably get a second of current before it shut it off, and that might be enough time to weld your wrench. So you just want to be real careful not to touch the wrench across a positive and negative terminal. I have the breakers off, so there's very little risk of that happening here. And I'm just gonna take this bolt off. And once I got both of them off, we'll be ready to go. The whole thing should come off. All right, let's try this with 2 wrenches. A little bit of wobble with a 1/2 inch. A little more wobble with a 13. I guess maybe it's not metric, it's probably a 1/2 inch. So put the 1/2 inch wrench on there, get a 1/2 inch socket, and go to town. Once you get it loose, you should be able to just take it off with your fingers. All right. There we go, one down. So still not completely disarmed. We still got a little bit of contact there, so let's move over to the negative terminal and we'll disarm that one as well. Same thing on the negative terminal. And just over here, the risk is these are positive wires here. And because this is an unfused system, this wire here is hot, and this one's also going to be hot as long as this breaker isn't tripped. So what I'm going to do is I'm going to pull this, and I'm going to move it out of the way, somewhere safe where it's not going to contact anything, because I do not want to arc weld my wrench. Now that should be safe. I don't think there's anything else in the way that could positively, or could cross from positive to negative. All right. Here we go. Looks like a nylock nut. Yeah. I guess the other one's nylock too. I just didn't notice before. Okay, that one's off too. Now the whole thing should just lift right off. Fingers crossed. There we go. There's our top plate. There's our battery. And I've got this nice little strap here holding this thing down. I'll have all of these products down below the video in the description. I just bought these. They're like marine grade, and they're very cool. I like them. little hold down strap. I guess this is a bit of an opportunity to show the wiring from an angle that I've never showed it from before. So this is what the underside of that panel looks like. And as you can see, I've got 3 positive terminals. This is my main 120 amp DC breaker. So this is the copper bus bar that I fabricated going on to the line side, I believe, and this is the load side. And so I've got 4/0 cable here attached to this lug, and then I've got 1, 2, 3. I believe these are 10 AWG cables coming off of here, and this one goes to the 30 amp breaker line side, and the load goes to the 45 amp Anderson connectors. And same thing over here, 3 10 gauge cables with I believe these are 5/16 ring terminals, and this one over here is a 3/8 ring terminal. And this is the Blue Sea Systems BMV 712 DC shunt. It is a 500 amp shunt. And actually, when I was wiring this up, I thought that I was going to strip this bolt or strip the inside threads, because with the combination of the 4/0 terminal lug and also these 3 3/8 10 gauge terminal lugs, I kind of ran out of threads, and also the washer and the lock nut. So what I did is, I believe it comes with a 15 millimeter bolt, 15 millimeter long bolt, brass. And so what I did is I bought a 20 millimeter long bolt in brass. And so for this one only, I will be replacing this bolt when I put it back together with the 20 millimeter bolt. And that way, I actually plan to add another 12 volt car receptacle to this unit. And so that way I've got room for that additional 12 volt car receptacle. I think I'm okay on the 5/16 studs to add another one. It's going to be a little tight, but I think I'll probably be all right. So I can't change those studs out even if I wanted to, as far as I know. So if I run out of stud thread on this one, I think my only option is to install a bus bar and connect once from here to the bus bar, and then go from the bus bar out to these other things. And that would be clean, but I'm kind of running out of room in here. There's not a whole lot of real estate available, so you know, hopefully I don't have to do that. All right, let's just continue with the teardown here. So I'll just start taking this thing apart. This thing's real simple. Let me get this out of the way so I got a little bit of room. It took me a little while to design it because, you know, you got to fiddle around inside the case, but it's pretty simple on the sides. It just has a few screws up here attaching this on that way, and a few screws here attaching the vertical that way. And then this one has screws mounted from the bottom through the plate. And so the reason why I did all of those different orientations is because wood is strong in certain dimensions and it's weak in other dimensions. And screws are strong this way, right? So in this direction, both ways, but they're not particularly strong in shear force. Nails are really strong in shear force. So I just wanted to make sure that when I designed it and I lifted it out of the case, it wasn't going to fall apart on me at some point. You know, things weren't going to pull free or strip or whatever. So, and I think I did a pretty good job of that. So in every connector, I think I've oriented it so that strong side meets strong side and nothing should come apart over time. Okay, so let's go ahead and remove some screws here. Kind of countersunk those a little bit. I got a bunch of different size screws. So these are the ones that I took out of the top. And then I believe some of the other ones are even smaller. So, and they're also made out of different materials. The ones on the top are made out of stainless, and the ones on the bottom are just zinc plated, I believe. I don't know, I just kind of got all fancy with the top ones because I think that stainless looks cool, so. It wasn't really a functional requirement. It was just something that I decided to do. Oop. All right, so there's one block at the top there. So these guys are the same length as the other ones. And there's our first vertical support. So this is actually just some scrap that I had laying around. I'll measure it and show you the dimensions later when I duplicate it, but there wasn't really a whole lot to this. It was just something that I had laying around that I could use. I'm not sure if I think I'm probably gonna have to fabricate some more of these because I don't think I have enough scrap to make another 3 sets. One of the nice things about having a woodworking shop in your basement is you end up collecting a lot of wood scraps. So it's kind of nice to, you know, sometimes it's annoying because you got too many of them, but it's kind of nice to use some of the scrap when you can. Kind of makes you feel like you're accomplishing something, repurposing. All right, there's my other vertical. Same thing, nothing really to it. All right, and here you can see the battery tie-down strap. It comes with these little connectors, and I believe it also comes with the screws. And these are also stainless, I believe. They're quite nice. Not sure I can get in close enough with the other screwdriver, so I will just ease up some pressure on this. Use a manual one. Little shorter and smaller diameter. Try not to strip anything. And actually, I'm being dumb. What I can do is I can just loosen up that strap from the top, and then I can remove this when the battery's out. That's what I did last time. Okay. Spin this guy around. Same thing here. Almost whacked myself. Block, countersunk holes. Oop. Oop. Try not to strip anything. I want to replace that one when I put it back in. I think it's still okay though. All right, and this guy can just slide out as well. And now the whole battery should come out of here. So Battleborn sells a strap that goes in here that allows you to carry these. They're sold separately. I did not buy one. So these are a little bit of a pain in the ass to move around. I can kind of put a fingernail in there and lift it, believe it or not, but it's really uncomfortable. So I think what I'm going to do here is I'm just going to kind of push it off the base with my fingers, slide it right off. There we go. Now I've got the base, and I can disassemble these parts as well. Okay, let's get all these parts out of the way here. I'll probably make a Tupperware, put all those in so I don't lose them. Okay, so in the front here, got these little cleaty guys. And this is just designed to keep the battery in place so that it doesn't slide front to back within the Pelican case. On the back here, the case comes right up to the back of the battery, so it's not a big deal, but on the front, I wanted to space it out a little bit so that I had some room. Again, these are just made out of scrap wood that I had laying around, but I'm sure that they do have a specific dimension, and when I duplicate them, I will have to use it. So that is something to be duplicated. It was fun. And there's that one, little countersunk hole there in the top. All right. So for the bottom plate, like I said, there are screws on the bottom holding it in place. And that is just so that I had a strong mating force between this block here and the bottom plate, because this is mostly going to be under tension this way, and so I wanted so that when I pull up on the battery, it lifts the whole thing up without coming out. So screws are strong. Screws are strong in this direction. They are weak in shear. So that's why I did that. These are a little longer, these screws, than the other ones. So the ones that went in the side were short screws, and these are slightly longer, but also smaller diameter, so I used more of them. When I started this, I just started using stuff that I had laying around. But as I got into the project, I started buying boxes of new stuff because I didn't have screws that were quite the right length. So I bought most of these at Ace Hardware. And when I'm reassembling it, I'll make sure to note what sizes they are. Woo! That was fun. Okay, so these blocks are pretty straightforward. They've got, I made some mistakes clearly. They've just got some holes drilled in them. Pretty much the same size. Doesn't have to be super accurate though. And there's our bottom plate. And so the bottom plate is probably the most complicated shape. You can see jigsaw marks as I cut this out. And the reason for that is the bottom of the Pelican case is sort of irregular. It will have high spots in certain places. It comes in and it's narrower than the top plate as well. The Pelican case is sort of a trapezoid. It kind of comes out like this at an angle as it goes up to the top. And so when I was making this, I mostly measured. I would measure across, and then once I had that dimension, I'd cut out a piece of wood, and then I'd try to shove it down in there, and I would measure this way. And for these stair steps and stuff, I would measure this length, and then I would measure from there to there. And I just kind of put it in there after I'd made all the cuts, and I tried to see if it would work. And it did. I did have a couple problems. There are little nubs that stick up from the bottom of the Pelican case in these two places, and so I drilled out these holes to allow those nubs to go in, and that just sort of serves as a way to locate the bottom plate inside the bottom of the case as well, but I just didn't want to break those off because I wasn't sure if they were important. They're probably just casting marks or something. But yeah, there it is. You can see I kind of made some other marks here for, you know, where things like this would go and things like that. But this will be easier when we duplicate it because all we'll do is we'll put this down on top of a piece of plywood and we'll trace it. And then, yeah, that'll be pretty straightforward. All right, anytime, you know, I do a project like this, it's real important to stay organized. So there's all my screws in a nice little Tupperware. That way I don't lose them and they're not getting everywhere. And then over here are all of the bottom plate pieces. Not super complicated. Set that aside. All right, and next, don't want to drop that knife on my foot. Next, let's remove all of the components from this piece. Most of these bolts on the Blue Sea Systems breakers are 14 millimeter. So we'll just start by removing these. And this is, you know, I'm real happy that we've got the whole plate off like this because this is, I actually installed these while it was on the unit. I'm not sure why I did it that way. It was kind of dumb, but this is way easier because there's no risk of getting electrocuted. Even if I short these two terminals, it doesn't matter because it's not hooked up to a battery. So it makes it real easy to work on. I'm definitely going to try to put it back together this way. And maybe the only two that I'll tighten after it's installed are the bus bar connectors. So you want to be real careful anytime you tighten these Blue Sea Systems bolts because I stripped one the other day. I was working on, this is a 150 amp breaker, and I tightened it too far. As you can see, I stripped the threads right off the post. So I am not aware of a way to repair that, so that's basically junk now. That's a paperweight. Kind of disappointing. These are about 60, 75 bucks. So you want to be real careful tightening these. They don't ever really stop turning. They'll just get kind of tighter and snug. And once they've gotten kind of snug, I think there's a torque specification, but I never use it. But once it gets fairly snug, you want to stop turning because you don't want to strip the post. I think it's just stainless steel or maybe tinned copper. It's fairly lightweight. And then what I like to do is once I've taken a nut off, I put it right back on, move on to the next one. The Victron data cable here, I have a crimper for Cat 5 cable, so I could shorten this if I wanted to. I'm just so damn lazy that I never have. But it's just a Cat 5 cable. You just reach in there, comes right out. Same thing on the back here. Comes right out. These guys just pop right off. Not really a huge fan of the quick disconnects. They come on and off really easily, but it's a little too easily for my taste. I think if I had it to do over again, I would prefer to use some screw terminals on those, but whatever. They do seem to work. Don't remember exactly what the nut size is for that, so give me just a second. Yeah, 17 millimeter. On the shunt. All right. And on the Blue Sea Systems shunt here, you get these little cables here, and these guys just come off with a screwdriver, and you just push on the little orange thing and pull on the wire. Comes right out. Kind of like a stereo speaker connector. Super not a fan of those. They're kind of a pain in the balls, but whatever. All right. All right, and kind of to toot my own horn here, let me get this focused. All right, so this, most of this stuff I bought, right? Like almost all of it I bought. The panel mount for my SB350 connector, I designed and printed myself. So I'm real proud of that. If anybody wants one of those, I will sell. I'll just leave me a comment down below the video in the description, and I will be happy to sell you one of these via PayPal, either the CAD file, the STL file so that you can print it out yourself, or I'll be happy to print one for you and send it to you. These are made out of ABS plastic, and I went through a number of revisions as I made these. So just in case you think to yourself, oh, I can make one of these myself, it's no big deal, he probably spent 5 seconds on this. No, dude. That's not the way 3D printing works. So these are all of the revisions that I went through before I ended up with this final model. And I do a lot of this. I design my own parts a lot and 3D print them, and this is par for the course, man. It's just a time-consuming, complicated thing. I have 2 years of CAD experience from high school. It was I lived close to a is it a stove factory? Maytag. I think it's a dishwasher factory, and they sponsored like a CAD course in my high school when I was a kid, and that was really, really cool. I learned a lot, and these days I put that to good use by making my own parts whenever I need to. 3D, for the longest time, you know, machine shop tools were kind of out of my range, but when 3D printing came along, I was like, damn, that is a perfect use for my CAD knowledge. So it's a lot of fun, and these are all different sizes. I mean, it's just, it took forever. It took a lot of time, and it takes about, I think it takes about 8 hours to print one of these, maybe 12. So, you know, if you need one, I got the hookup. I'll even upload this to Shapeways so that you can just buy it online if you want. But let me know if you want it down in this description below. If you don't, no big deal. I won't waste my time. So let me figure out how to get this thing off. I don't remember what the nut size is. Stainless hardware, 1/4 thread, nylock nut. And these studs just hold the SB350 connector in the panel mount. There are threads on the other side that hold it. then mount it to the piece of plywood. All right, and with those two screws out, the SB350 connector slides right out. There's my 4/0 cable. Set that aside. Okay, now we can start removing things. So the Victron is just in with a screw. It's got this little, I don't know what they call it, bevel, screw, whatever. And then it just drops off when you take that off. Pretty straightforward. And this guy comes off with a screwdriver. I actually just use a regular screwdriver so I don't strip that. Stainless steel. Pop those into my screw container. So the shunt is free now. All right, and then these two also come off with their own like little screw thing on the back. That one also has one on the front though. I cut all of these holes with, not a hole saw, what's the other thing called? Fancier version of a hole saw, what are they called? Anyway, I cut them on the drill press. All right, so now all of that is out and we can focus on removing these screws here. So, got some of these. Oh, this one comes out pretty much by hand. I think you can use a socket on it as well. Just slides right out after that. You can kind of see there's a recessed hole there. I cut that with a chisel. Suppose I could have used a router or something, but I'm not that fancy. I like to use hand tools when I can. I feel like they're, you know, unless you're repeating something a bunch of times, I feel like they're more natural. I don't know. Screwdrivers being the obvious exception to that rule. .12-volt socket. Comes with a little front panel that just kind of rests on there like that. And it's got one of those rings on the back that tightens it down. Pretty cool. And the breakers come out with these guys. And they just slide right out. No big deal. There we go. All right, and these are, I bought these on Amazon, these little, they're like in home and kitchen or something. They're stainless steel, I believe. Highly recommend these, I really like them. Have those links down below the video in the description. And you can see my SB350 panel mount. This white stuff here is, I use glue when I attach it to the build plate. And so that's a little bit of glue. You could probably sand that off. It wouldn't be a big deal if you don't like the way that looks. I don't really care, so I just leave it on. But this mount is designed specifically for putting into a Pelican 1440 case because it doesn't have an equal number of screws. And it's thicker here than it is there, so that it just slides right in. But, you know, it would work for anything, but it might look a little strange in other places. So keep that in mind if you order one from me. There we go. And then that just slides out as well. Okay, I think my camera battery's almost dead, so I think I'm gonna pinch this video off and then I'll do another video in the series where I duplicate these pieces. Check out the parts down below the video in the description if you're interested in any of those. It just helps support the channel. You don't pay a dime extra, but they are affiliate links, so just be aware of that. It does help support the channel. Thanks for watching and please subscribe.